Structure of the atom. Question 1. Electron always occupy the lowest empty energy level. Now, this statement is in quotes. Electron always occupy the lowest empty energy level is a statement of. Now, this statement that says that when electrons occupy orbitals, they will occupy orbitals of lower energy levels first before occupying orbitals of higher energy level. This statement is the statement of Aufbau. So this is the Aufbau's principle. Now, Pauli's exclusion principle explains that a pair of electrons cannot have the same value for all the quantum numbers, while the periodic law tells us that the properties of an atom is a function of its atomic number or proton number and not its atomic mass. While Hund's rule of maximum multiplicity states that electrons occupy orbitals singly before pairing takes place. So the principle that explains that electrons will occupy orbitals of lower energy level before occupying orbitals of higher energy level is the Aufbau's principle. So that leaves us with option D as our correct answer. Question 2. A beam of particles was passed between a charged plate as illustrated in the diagram. X, Y, and Z are respectively. Alright, let's look at the charge field. Now this is the field, this is the negative terminal, this is the positive terminal. Now the law of electrostatics explains to us that like charges repel each other, meaning that positive and positive will repel, or negative and negative will repel. Then unlike charges will attract. Unlike charges will attract each other. That is, positive and negative will attract, or negative and positive will attract. So what this means here is that for X to be attracted towards the negative terminal, it means that X must be carrying a charge that is opposite to the negative terminal. That means X is carrying a positive charge. And then for Z to be attracted or deflected by the positive terminal, it means that Z must be carrying a charge opposite to the positive terminal, which is negative. And then for Y not to be deflected by either the negative terminal or the positive terminal, it means that Y has no charge. Y is neutral. So that means X is positive, Y is neutral, and Z is negative. Now, based on this information, our correct answer would be to X. If X is positive, the particle of the atom that is positive is the proton. And if Y is 0 or neutral, the particle of the atom that is neutral is the neutron. And if Z is negative, the subatomic particle that has a negative charge is the electron. So in that order, X, Y, and Z, so it's proton, neutron, and electron. That gives us option A as our correct answer. Question 3. A hydrogen atom which has lost an electron contains. Now, a hydrogen atom has the configuration 1:1. That is, the proton number is 1. This is the proton number. And this is the atomic mass. This is the atomic mass. And if I decide to draw the electronic configuration, it means that hydrogen has only an electron because the number of electron is equal to the number of proton. So if this hydrogen atom has 1 proton, it means it automatically has just an electron. And in the nucleus is the single proton. So the question says a hydrogen atom which has lost an electron. So if it loses this electron, which is the only electron it has, what is left of it is simply a proton. What is left of it is simply a proton. So a hydrogen atom which has lost an electron contains 1 proton only. So our correct answer is the option B. Now option C is not the answer because even though it contains a proton, there is no more electron and there is no neutron because neutron number is actually the atomic mass minus the proton number. And if you do that here, atomic mass is 1, proton number is 1, so that gives us 0. So this hydrogen atom has no neutron. Question 4. A metallic ion Z2+ with an inert gas structure contains 18 electrons. 18 electrons. How many protons are contained in this ion? Now, let us start by establishing the fact that in a neutral atom, the proton number is always equal to the electron number. That explains why an atom is electrically neutral. The proton number is equal to the electron number. Now, this is an ion with the charge 2+. Now, for it to possess the charge 2+, it means that this ion was formed by the loss of 2 electrons. It was formed by the loss of 2 electrons. So as a result of that, it now has 2 protons more than electrons. So the number of protons in this particular ion still remain 20, while the electrons now, because it has lost 2 electrons, the electrons become 18. 20 minus 18 gives us an extra of 2 protons. So its proton number remains 20. So our answer in this case is the option A. Question 5. A molecule of phosphorus is, now a molecule of phosphorus is actually tetraatomic. Phosphorus is in group group 5 of the periodic table. So each phosphorus atom will require 3 electrons to become stable. It will now undergo covalent bond with itself to form a triatomic molecule. So our answer is the option A. Question 6. A sodium atom and a sodium ion have the same. Now, this is an atom, this is an ion. So a sodium atom has 11 protons, 23 atomic mass. A sodium ion has a charge of +1 because it has lost one of its valence electrons, but protons still remain intact at 11 and atomic mass remain 23. So this is neutral, while this is charged. Now the question is asking us, what is similar? What is similar? So clearly from here we've seen that proton numbers remain the same, atomic mass remain the same. However, the number of electrons are not the same. The proton number is always equal to the electron number in a neutral atom. So this sodium here has 11 electrons, while this sodium here, because it has lost one of its electrons, it has 10 electrons. So let's look at our options. A, the same number of electrons. We've established that the number of electrons are not the same. The ion has fewer electrons than the atom. Option B, the same number of neutrons. The same number of neutrons. To get the number of neutrons, it will be the atomic mass minus the proton number. So let's quickly check that. 23 minus 11 gives us 12 neutrons for this atom, and for this ion 23 minus 11 also gives us 11 neutrons. So clearly here we can see that the number of neutrons are the same. But just to be sure, let's move on to option C. Electronic structure. The electronic structure is the arrangement of the electrons. Now this one here has 11 electrons, so the electronic structure is 2, 8, 1, while this one now has only 10 electrons because it has lost its valence electron, so the electronic structure is 2, 8. So clearly we can see that the the electronic structure not the same, number of electrons not the same, number of neutrons the same. Now electric charge. The sodium atom has a neutral charge because the number of protons equals the number of electrons, while the sodium ion possesses an electrical charge because the number of protons are more than the number of electrons. So this one again not the same. That leaves us with option B as our answer, that they have the same number of neutrons. So option B is our answer. Question 7. Allotropes of an element differ in their. Now, to answer this question, one needs to understand the definition of allotropy. Now, allotropy is a phenomenon in which atoms of the same element possess the same chemical properties but different physical properties. Atoms of the same elements possess different physical properties but the same chemical properties. So what differentiates allotropes is the fact that they possess different physical properties. For example, if you look at carbon has various allotropes such as charcoal, diamond. Now, using these two examples, in terms of physical properties, charcoal is different from diamond. Diamond is the hardest substance known. It is the densest substance known, and charcoal is not does not have high density, but they are all forms of carbon. So clearly we've seen that chemical properties are the same, but physical properties are different. So that leaves us with option A as our answer. Question 8. An atom of element X gains 2 electrons. The symbol of the ion formed is, now in every atom, the number of protons is always equal to the number of electrons. So let's pretend that this element X has 12 protons. It also means that it's going to have 12 electrons. Now we've just been made to understand that X now gains 2 electrons. So if it gains 2 electrons, so we're having an extra 2 electrons here now, it means that while the proton number remains 12, the number of electrons now become 14. Now if we look at the difference, there is an extra 2 electrons. So its charge would now be a 2 minus, because we have 2 electrons extra than protons. So that leaves us with option A as our answer. Question 9. An atom with 17 protons, 17 electrons, and 18 neutrons has a mass number of, now the mass number of an atom is equal to the number of protons plus the number of neutrons. So if we plug in these values, the mass number is equal to 17 protons plus 18 neutrons, and that gives us 35. So our answer is 35. Question 10. An atom W has 17 electrons, 18 neutrons. Which of the following representations of the atom is correct? Now let's write the element W. The number written at the top is the atomic mass, indicated by the alphabet A, atomic mass, while the number written at the bottom is the proton number, indicated by the alphabet Z. Now A, which is the atomic mass, is equal to proton number plus neutron number, while Z is the number of protons. So if we want to follow this configuration, if it has 18 neutrons and 17 electrons, now I want us to remember that the proton number in any atom is always equal to the number of electrons. Proton number is equal to electron number. So if the electron number is 17, it automatically means that there will be 17 protons. So 17 comes down here as our proton number. Then if we have 18 neutrons and we now know that there are 17 protons, then our atomic mass would be proton number, which is 17, plus neutron number, which is 18. And that gives us 35. So the representation of this atom is 35, 17. Atomic mass 35, proton number 17. So that leaves us with the option D as our correct answer. Question 11. An atom X contains 6 protons, 6 electrons, and 7 neutrons. Which of the following representation of the atom is correct? If we take X as the atom or the element, the number written at the top is the atomic mass, represented by the alphabet A, while the number written at the bottom is the proton number, represented by the alphabet Z. Atomic mass A is equal to proton number Z plus neutron number. So if we apply this, if the atom has 6 protons, it means that the proton number is 6. And then if it has 7 neutrons, the atomic mass is equal to proton number, which is 6, plus the neutron number, which is 7. 6 plus 7 gives us 13. So atomic mass is 13. And the option with this representation is option B. So option B is our answer. 13, 6. Question 12. An element which can exist in 2 or more forms in the same physical state. Now this is the definition of allotropy. Allotropy. For example, carbon can exist as charcoal. It can exist as diamond. It can exist as graphite. Now, they are all forms of the same element, carbon. Another unique example is sulfur, where we can see monoclinic sulfur, rhombic sulfur, plastic sulfur. Now, they are all forms of the same physical state, sulfur. So our answer is allotropy. Option C. Question 13. An element with mass number 133 and atomic number 55 has, okay, let's pretend that the element is X. Mass number is written at the top, so we're going to represent 133 here, and atomic number or proton number is written as the base. We're going to write 55 here. Now it's asking us which of these options describes this atom. Now, so this is proton number, this is atomic mass. Now, atomic mass is equal to proton number plus the number of neutrons. So let's get the number of neutrons in this particular atom. If neutrons would now be atomic mass minus number of protons. So the number of neutrons would now be 133 minus 55, which would now give us 78. So this atom has 78 neutrons. So 55 protons. And remember that proton number is the same as electron number. So we also have 55 electrons. And then we have 78 neutrons. So let's check. 78 electrons and 78 neutrons, no. 55 electrons and 55 neutrons, no, this disqualifies it. 55 electrons and 78 neutrons, this is true. 78 neutrons, 55 neutrons, no. So our answer is the option C, which gives us the correct number of electrons and neutrons. Question 14. An element X has an atomic number of 16. What is the most likely oxidation state in its binary compound? Now, if the element has an atomic number of 16, it means that it also has 16 electrons. 16 electrons. Now, the electronic configuration of an element is done using its number of electrons. And when the configuration is done, the number of valence electrons would determine its oxidation state. So let's do this configuration using the principal energy levels. It will be the K shell takes 2 electrons. All other shells take a maximum of 8 electrons. So that will be 2, 8, 6. 2 plus 8 plus 6 is 16. So this is the configuration of this particular atom. Looking at it this way, it will need 2 electrons to become stable. So when it takes part in a chemical reaction, it is going to accept 2 electrons from the other atom. It's going to accept 2 electrons from the other atom. By accepting 2 electrons, that confers on it a charge of -2, because protons are currently 16. And also electrons are currently 16. From what we said, proton number equals to electron number. However, based on this configuration, it will need to accept 2 electrons so that its configuration becomes 288 to attain the octet configuration or the noble gas configuration. So it's going to acquire 2 extra electrons so that now we have 18 electrons. And that explains the charge of -2. So our answer is the option C. Question 15. An element has 2 isotopes, X65 and X66. Yes, sometimes it is written as X65. We write the atom and then its atomic mass, and then X66 with relative abundance of 60 and 40 respectively. So this is 60% and this abundance is 40%. The relative atomic mass of X is, now to get the relative atomic mass of X, we need to get the relative atomic mass of each of these isotopes and then combine them using the simple formula. Relative atomic mass is equal to the atomic mass times the relative abundance, which for the first element is 60%. Now 60% is same as over 100, plus the atomic mass of the second isotope multiplied by its own relative abundance, which is 40%. So now let's plug these values in. For the first one, it's 65. So we have 65 times 65 times 60 divided by 100 plus 66 times 40 divided by 100. Now, if we work this out, 65 times 60 is 3,900 divided by 100. That will give us 39, plus then 66 times 40 would give us 2,640 divided by 100. That would give us 26.4. 26.4 plus 39 would give us 65.4. So the option that agrees with this answer is option D, and that is our answer. So that is how you calculate the relative atomic mass of isotopes. All you need to do is multiply the relative abundance by the atomic mass of each element of each isotope, and then add up everything, and that gives you the relative atomic mass. Question 16. Atomic orbital is, now by definition, an orbital is simply a region or space outside the nucleus where there is a probability of locating an electron. So if this were to be the nucleus of an atom, an orbital is any region or space outside the nucleus where it is possible to locate an electron. So it's not a defined path like we talk about shells. No, it is just a region outside the nucleus where it is possible that we can locate an electron. So let's look at our options. Option A, the path around the nucleus through which protons move. Now protons do not move around the nucleus. Protons are located within the nucleus, so this option is not correct. Option B, the path around the nucleus through which electrons move. Now, like I said, orbitals are not defined paths like shells, so this does not agree. Option C, the circular path through which electrons revolve around the nucleus. Now, option C is actually the same as option B. It's just semantics now, or the use of language there. So no, option D says a region around the nucleus where electrons are most likely to be found. This clearly answers or corresponds to our definition of what an orbital is. So our correct answer is option D. Question 17. Atoms are electrically neutral because, now to be electrically neutral means to have no charge. To have no charge. Now, every atom has three subatomic particles: proton, neutron, and an electron. Now, the protons are positively charged, the neutrons are neutral or no charge, the electrons are negatively charged. Now, in every atom, the number of protons always equal the number of electrons. So if an atom has 11 protons, it would as well possess 11 electrons. So 11 positive charges and 11 negative charges, they would cancel out. So the reason why an atom is neutral is because atoms have equal number of positive protons and negative electrons. So let's look at the options. A, they are composed of neutrons and electrons. Now neutrons, we just said, are neutral, so that disqualifies this option. B, contains equal number of protons and electrons. This agrees with our statement here, so this is our correct answer. So we will pick option B. Question 18. Calcium atom ionizes by, let's define what ionize means. To ionize simply means to become an ion. Ionization is a process whereby an atom becomes an ion. And an atom becomes an ion either by gaining electrons or by losing electrons. So when it gains electrons, it becomes a negatively charged ion called an anion, because it has more electrons now than protons. Then when it loses electrons, it becomes a positively charged ion called cation, because it has more protons now than electrons. Now, to answer for calcium, we need to ask ourselves the question, what kind of element is calcium? Calcium is a metal. Now, metallic atoms are known to lose electrons, while non-metallic atoms are known to gain electrons. This knowledge is from chemical bonding. So if calcium is a metal, it means that calcium will become an ion by losing electrons. Now, how many electrons will calcium lose will be determined by its group in the periodic table. Calcium belongs to group 2 in the periodic table, or we can as well use the electronic configuration of calcium. Calcium's proton number is 20. That means it also has 20 electrons. So the configuration will be 2, 8, 8, 2. Group 2, the number of valence electrons tells us the group of the atom, and the number of valence electrons tells us the electrons it would lose. That means calcium will lose 2 electrons, lose 2 of its valence electrons. So let's look at the options now. Calcium atom ionizes by sharing 2 electrons. It does not share, it's a metal. By gaining 2 protons, it cannot gain protons. By gaining 2 electrons, it's a metal. It cannot gain electrons, it can only lose electrons. By losing 2 electrons, yes, this is correct. So our answer is the option D. That calcium ionizes by losing 2 electrons. Question 19. Chlorine atom forms chlorine atom forms let's pretend this is chloride. Chlorine atom forms chloride. Now chlorine atom has the proton number 17. That means it also has 17 electrons. So if we should do the configuration, first shell takes 2, second shell takes 8, the next shell takes 7. Now that means it needs only 1 electron to be stable. So when it receives or it gains an electron from another atom, its configuration will now change to 288. But what this simply means here is that it now has an extra electron compared to proton, so it's going to acquire a charge of 1 minus, or just a minus, 1 minus, or just a minus. So chlorine atom forms chloride by losing 1 electron, no. Donating lone pair of electrons, no. Pairing 1 electron, no. Gaining 1 electron, yes. So option D is our correct answer from the analogy we have here. Question 20. Compounds that have the same molecular formula but different structures or structural formula are said to be. Now, there is a concept called isomerism. Isomerism, where these compounds have the same molecular formula. For example, C4H10. This is butane. And we can as well have another compound with C4H10. However, the arrangement of the atoms, which is the structural formula, are not the same. So such compounds are called isomers. They are called isomers of each other. So compounds that have the same molecular formula but different structural formula are said to be isomeric. So our answer is the option A. Question 21. Find the number of neutrons in an atom represented by. Now, if X is the atom, the number written at the top here is the atomic mass, while the number written at the bottom is the proton number represented by the alphabet Z. And the atomic mass A is equal to the proton number plus the number of neutrons. So if we take this formula into consideration, it means our atomic mass 45 is equal to our proton number is 21 plus our neutron number n. It therefore means that our neutron number n is equal to 45 minus 21, which gives us 24 neutrons. So our answer is the option C. Question 22. Given only the atomic number of an element, it is possible to determine the number of. So again, if I represent an element as X and its atomic number is written as the base, that is the alphabet Z, and the atomic number Z is the same as the proton number, now, given only this atomic number, what can I determine? I can determine the protons in its nucleus, because proton number is defined as the number of protons in the nucleus of an atom. unpaired electrons present? Yes, because proton number is equal to electron number. For example, if I have 11 protons in an atom, it means I'm also going to have 11 electrons. Electrons in the outermost shell? Yes. The proton number is equal to the electron number. So if I have 11 protons, that gives me 11 electrons as well. I can now use this to do the electronic configuration or draw the electronic structure of that atom, and that would tell me the electrons in the outermost shell. And then 5, the neutrons in its nucleus. No, the number of protons does not relate in any way to the number of neutrons. The only relationship here is when it comes to atomic mass, where the atomic mass of the element is the sum of protons and the neutrons. But by no means does the number of without the atomic mass, we cannot determine the number of neutrons. So based on this information, our correct answer is the option C. 1, 2, and 3 only can be used to relate to the atomic number of an atom. Question 23. Given the symbol Y4020, so 4020, it can be deducted that Y has, the number 40 represents the atomic mass of the element, represented by the symbol A, and the number 20 represents the proton number of the element, represented by the letter Z. Now, atomic mass A is equal to proton number plus neutron number. So if atomic mass is 40, it therefore, and proton number is 20, it therefore means that my neutron number N would be equal to 40 minus 20, which is equal to 20 neutrons. It means that in this atom, we have 20 protons, we have 20 neutrons, and because it is an atom, the number of protons in an atom is always equal to the number of electrons. So we're also going to have 20 electrons. So given the symbol 4020Y, it can be deducted that Y has 60 neutrons. No, we've established that the neutrons are 20, a mass number of 60. Mass number is also called atomic mass. This is true. An atomic number of 20. Atomic number is the number of protons in the nucleus of an atom. Yes. Question 23. Given the symbol 4020Y, it can be deducted that Y has, let us look at what Y is all about. Now, the number 40 is the atomic mass of Y, represented by the alphabet A. The number 20 is the proton number or atomic number of Y, represented by the alphabet Z. So what this tells us here is that element Y has 20 protons, and because in a neutral atom the number of protons is always equal to the number of electrons, it also means that in atom Y there are 20 electrons. Now we need to determine the number of neutrons. Now the number of neutrons is obtained from the formula that atomic mass is equal to proton number plus neutron number. Therefore, neutron number is equal to atomic mass minus proton number. If we plug in the values, atomic mass is 40, proton number is 20. That means we have 20 neutrons in this atom. So let's look at our options. Again, given that the symbol 4020Y, it can be deduced that Y has 60 neutrons. We've established that the neutrons are 20, so this is not true. A mass number of 60, the mass number or atomic mass is 40, so this is not true. An atomic number of 20, atomic number is the same as proton number. We've established that the protons are 20, so this is true. 40 electrons, we've established that the number of electrons in a neutral atom is always equal to the number of protons, so the electrons are 20 and not 40, so this is not true. It therefore means that our correct answer is the option C. Question 24. How many electrons are present in beryllium ion? So let's look at it this way. Beryllium ion 2 plus, atomic mass is 9, proton number is 4. Now remember that proton number is always equal to electron number. So if this beryllium ion has 4 protons, then there should be 4 electrons. However, we have clearly seen that there's a charge of 2 plus here. Now what this means is that beryllium has lost 2 of its electrons. It has lost 2 of its electrons, so there are 2 protons extra. So what it therefore means is that in beryllium ion we have 4 protons against 2 electrons. Now this is what is supposed to obtain in the neutral atom, and this is what obtains in the ion. 2 electrons have been lost, and so we have 2 protons extra than electrons, and that explains this charge. So going back to our question, how many electrons are present in beryllium ion? It simply means that we have only 2 electrons because 2 electrons have been lost. So our correct answer is the option D. Question 25. How many electrons does phosphide contain? Phosphide, this is phosphide. The ion of phosphorus is called phosphide. How many electrons? Our focus again is on electrons. So let's bring out the configuration. Phosphide is 31, 15 with a charge of 3 minus. Now, the proton number in any atom is always equal to the number of electrons. So let's look at a phosphorus atom. If it has 15 protons, it means that it's going to have 15 electrons equal. But now this is phosphide, which is an ion of phosphorus, and the sign here tells us that it has gained 3 more electrons. It has gained 3 more electrons. So we have 15 protons as against 15 electrons plus the 3 gained electrons. That gives us 15 protons against 18 electrons. That means in phosphide ion it contains 18 electrons. Therefore our correct answer is 18 electrons. Question 26. How many orbitals are contained in an atom with atomic number 13? Now, to start with answering this question, the atomic number 13 corresponds to the number of electrons in that atom. So if the atomic number or the proton number is 13, it means that the electron number will also be 13. Now, to determine how many orbitals are in an atom with this atomic or proton number, we need to apply the Aufbau's principle, which tells us how electrons will occupy orbitals. And the Aufbau's principle states that when electrons are occupying orbitals, they will occupy orbitals of lower energy level before occupying orbitals of higher energy level. So let's write the Aufbau's formula. So let me stop at 5. And then the next will be the p orbital. And the d orbital, and then the f orbital. Now, according to this arrangement, the orbital of the lowest energy level is 1s, as my arrow moves, then 2s, then 2p, then 3s, then 3p, then 4s. It goes like that. Now let's do the configuration. The first orbital there of the lowest energy level is the 1s orbital. So 1s. Now the s orbital can take a maximum of 2 electrons. The p orbital can take a maximum of 6 electrons. The d orbital can take a maximum of 10 electrons. And the f orbital can take a maximum of 14 electrons. So following this, it means that the s will take a maximum of 2 electrons. Now 2 out of 13, we are left with 11 electrons. The next orbital is the 2s orbital. Again, s will take a maximum of 2 electrons. That's 4 electrons out now. We're now left with 9 electrons. The next orbital is the 2p orbital. And the 2p orbital or the p orbital will take a maximum of 6 electrons. This gives us a total of 10 electrons. We still have 3 electrons to go. The next orbital after the 2p orbital is the 3s orbital. And s can take a maximum of 2 electrons. So 2 will go in there. Now we've exhausted 12 electrons. We're left with 1. The next orbital is the 3p orbital. Now the p orbital can take a maximum of 6 electrons. However, we're left with just 1 electron. So we're going to plug the 1 there. And to be sure, we count 2 plus 2 is 4, plus 6 is 10, plus 2, 12, plus 1, 13. So 13 electrons cleared. Now let's count the number of orbitals. This is orbital 1. This is orbital 2. This is orbital 3. This is orbital 4. And this is orbital 5. It means that an atom that has a proton number of 13 would have 5 orbitals. So our correct answer is the option D, which is 5 orbitals. Question 27. How many protons does calcium atom contain? So calcium atom shows us that it has an atomic mass of 40 and it has a proton number or atomic number of 20. So the number written at the base here is the proton number or the atomic number, while the number written at the top here is the atomic mass, which is the sum of the protons and the neutrons in the nucleus of the atom. So what this simply means is that the proton number of calcium is 20. So our correct answer is the option D. Question 28. If an atom is represented by X3919, which of the following deduction is correct? So quickly, let us look at what these numbers mean. Now, the number 19 is the atomic number or the proton number. And in an atom, the proton number is always equal to the number of electrons. So 19 will also represent electron number. Now, the number at the top, that is 39, is the atomic mass or the mass number. And the atomic mass is the sum of protons and neutrons in the nucleus of the atom. So let's now find out the number of neutrons, since we already know proton number and electron number. So let's plug in these values. Atomic mass is 39 is equal to proton number is 19 plus our neutron number. It therefore means that our neutron number is 39 minus 19, which is 20 neutrons. So now that we're equipped with this information, we can actually determine whatever information that is expected of us in this question. So the question is saying which of the following deduction is correct? Its atomic number is 39, atomic number is 19, which is the same as proton number. So this deduction is not correct. It contains 20 protons. Proton number, as we can see here, is 19. Proton number is the same as atomic number, so this deduction is not correct. Option C, it forms a covalent chloride. It forms a covalent chloride. Now let's look at this configuration. If it has 19 electrons, using the principal energy levels or the shell configuration, the configuration will be 2 8 8 1. Now that means it has one valence electron. That makes it a group 1 metal. That makes it a group 1 metal because it has one valence electron. Now group 1 metals do not form covalent molecules. They do not form covalent compounds. So this information is not true. Option D says it is an alkali metal. From our knowledge of the periodic table, group 1 metals are called the alkali metals, while the group 2 metals are called the alkaline earth metals. So this is a group 1 element, and group 1 elements or metals are referred to as the alkali metals. So this information or deduction is correct. That means our answer is D. Mass of the gas is equal to 11 gram. We also know the volume occupied by the mass of this gas. The volume occupied by this 11 gram is 5.6 dm cube. Now we have an important information here that 1 mole of a gas occupies 22.4 dm cube. Now we're interested in the vapor density. Now one formula that relates the mass of an atom or substance or gas to its vapor density is molar mass is equal to twice the vapor density. Now, we can use this information to compute the molar mass of this gas. Now, if we know that 1 mole of a gas at STP will occupy 22.4 dm cube, then we ask ourselves, how many moles of this gas will occupy 5.6 dm cube? 1 mole of a gas is the standard at STP will occupy 22.4 dm cube. Then how many moles of this 11 gram of this gas will occupy 5.6 dm cube? Now, if we work that out, it will be 1 times 5.6 divided by 22.4. That's x mole is equal to 5.6 dm cube times 1 mole divided by 22.4 dm cube, and this would give us 0.25 moles. So we now know that 0.25 mole of this gas will occupy 5.6 dm cube. Now we need to convert this. Now we have this information and we also have the mass of the gas, so we can actually use these two information to compute the molar mass. Now there is a formula that says that the number of moles, and this is coming from the mole concept, that number of moles is equal to mass of a substance divided by its molar mass. Now we know the mass as 11 gram. We know the number of moles as 0.25 mole. So if we make molar mass the subject of the formula, it will be molar mass is equal to mass over number of moles. If we plug in the values, that would give us 11 divided by 0.25, which is equivalent or equal to 44. And because it's molar mass, 44 gram per mole. Now let's go back to the formula that connects molar mass to vapor density. So if molar mass is equal to twice vapor density, it means that 44 is equal to 2 Vd vapor density, and therefore vapor density is equal to 44 divided by 2. So that gives us 22 as our answer. So let's check our options where we have 22. The answer is the option C. Question 30. Isoelectronic species have the same number of. Now iso translates as the same or equal, and then electronic translates as electron. So isoelectronic species have the same number of. The rough translation is electrons. So our correct answer is the option C. Question 31. Isotopes of a given element have the same Now we need to understand the definition of isotopes. Now isotopes are atoms of the same element. They are atoms of the same element that have the same proton number but different atomic mass. For example, if I pick oxygen and I have oxygen as proton number 8, I have oxygen 16, then I have another oxygen proton number 8 but 17. Now the proton number determines the identity of an atom, and that's why both of them are still oxygen or retain the identity oxygen, because the proton numbers determine identity and the proton numbers are the same. Now what differs here is the atomic mass, and the component of the atomic mass that makes them differ is the number of neutrons. The number of neutrons. To get the number of neutrons, it's atomic mass minus proton number. So 16 minus 8 here gives us 8 neutrons. And then 17 minus 8 here gives us 9 neutrons. So isotopes of the same element differ in the number of their neutrons. Now based on this information, let's look at our options. Isotopes of a given element have the same atomic number. Yes, they have the same atomic number, 8 and 8. Electronic configuration. Now this is true, they have the same electronic configuration. Why is that so? Proton number is the same as electron number, so it means that we have 8 electrons in oxygen 16 and 8 electrons in oxygen 17. So if we do the configuration, it will still be 2 6 2 6. Chemical properties, this is also true, they have the same chemical properties. Now the chemical property of an atom is determined by the number of valence electrons. The number of valence electrons determines the chemical property of an atom, and from the electronic configuration we can see that oxygen 16 has 6 valence electrons and oxygen 17 also has 6 valence electrons, so chemical properties will be the same. And 4 says mass number. We can clearly see here that the mass numbers are not the same, and this is because of the difference in the number of neutrons. So clearly, based on this information, it says isotopes of a given element have the same, so they have the same atomic number, electronic configuration, chemical properties. So our answer is 1, 2 and 3, which is option C. Question 32. Pauli's exclusion principle is related to. Now let us look at what this principle is talking about. Now Pauli's exclusion principle is one among the principles that explains the quantum mechanical model of the atom. It explains the electronic configuration of atoms. Now Pauli's exclusion principle states that no 2 electrons occupying the same energy level, that no 2 electrons occupying the same energy level or orbital will have the same values for the 4 quantum numbers. The 4 quantum numbers are the principal quantum number, then the second one is the subsidiary, or what you call the azimuthal quantum number. Then the third one is what we call the magnetic quantum number. And the fourth one is the spin quantum number. Now, this principle states that two electrons occupying the same orbital cannot have the same values for these four numbers we just mentioned. So they can have the same number for these first three, but they will not possess the same spin. So that if one electron spins clockwise, the other electron will spin anti-clockwise. They cannot all spin in the same direction. What this means is that Pauli's exclusion principle is related to the quantum numbers of electrons. So our correct answer is the option B. This principle has to do with the quantum numbers of electrons, that no two electrons occupying the same orbital will have the same values for the four quantum numbers. Question 33. Polyatomicity is illustrated by molecules of. Okay, to answer this question, we need to understand the definition of polyatomicity. The word poly is from the Greek word meaning many, and then atomicity simply means atoms. So polyatomicity or polyatomic, many atoms. If we put this in the definition, a polyatomic molecule is a molecule that is made up of more than 3 atoms of an element. It is a molecule that is made up of more than 3 atoms of an element. Now, a noble gas, or all the noble gases, are monoatomic. They are unreactive in nature, so they do not combine with any other atom, and neither do they combine with themselves, so they are monoatomic. Liquefied oxygen is diatomic. Our definition says that for any molecule to qualify as polyatomic, it needs to be made up of more than 3. Carbon 4 oxide, so liquefied oxygen is diatomic. Now for carbon dioxide, the formula is CO2. Now let's look at this. Carbon is 1 atom, and then oxygen will have 2 atoms. So that gives us a total of 3 atoms. This is triatomic. Now let's look at our definition again. It says polyatomicity, the molecule must contain more than 3. It does not say more than 2 or 3. It says more than 3. So because carbon 4 oxide is made up of exactly 3 atoms, triatomic, that means it is not polyatomic. Now sulfur, a molecule of sulfur is made up of 8 atoms. Now this qualifies as polyatomic because we have more than 3 atoms. What this therefore means is that our correct answer is the option D, sulfur, because it is made up of more than 3 atoms. Question 34. Protons and electrons are called fundamental particles because. Now, protons and electrons are subatomic particles, and the atom has 3 main subatomic particles. the proton, which has a positive charge, the electron, which has a negative charge, and the neutron, which is neutral, no charge. Now, to answer this question, we need to understand the definition of fundamental, or what qualifies a particle to be considered fundamental. Now, according to the modern definition, fundamental particles are particles that are so simple that they cannot be broken down into smaller forms. They are so simple that they cannot be broken down into smaller forms. And currently, only the electrons are considered to be fundamental. Currently, only electrons are considered to be fundamental. The protons used to be in the list, the neutrons used to be in the list, but there are evidence now that the protons and the neutrons can be split into smaller, simpler particles. For example, the protons can be split into smaller particles called quarks. So, but the electron cannot be split into any smaller particle. So now let's look at our options. Protons and electrons are called fundamental particles. So even though protons are included in our question, but let's focus on the electrons. And like I said, the electrons are considered fundamental, or the term fundamental means we cannot be broken down into any simpler form. So let's look at our options. Indivisible means cannot be broken down into any simpler form. This answers the question of what is fundamental. Have different charges based on the modern definition? No. Are the lightest particles? No. Are found in all matter? This used to be part of the definition of being fundamental, but currently the only definition is that a substance is indivisible. So our correct answer is the option A. Question 35. Scientists whose experiment gave evidence about the nature and structure of the atom include. Now let's look at their contributions. J.J. Thomson was the one that established the plum pudding model. The plum pudding model of the atom. Describing the atom as a giant mass as a sphere with a giant positive center. Lord Ernest Rutherford was the one that established that electrons were located outside the nucleus in spherical parts called orbits. Sometimes he's attributed to the planetary model of the atom, where the electrons are in shells or orbits. Now, Le Chatelier was not actually involved in experiments about the atom. Le Chatelier actually studied systems in equilibrium and what happens to such systems when they are disturbed either by a change in pressure, concentration, or temperature. And then Robert Boyle studied the relationship between the pressure of a given mass of gas and the volume, and was able to establish an inverse relationship that pressure is inversely proportional to volume, and that gave us Boyle's law. So the only scientists here that contributed or carried out experiments to determine the nature and structure of the atom are J.J. Thomson and Lord Rutherford. That is 1 and 2. This means that our correct option is 1 and 2 only. Option C is our correct answer. Question 36. The atom of an element X is represented as XYZ. XYZ. The basic chemical properties of X depend on the value. The basic chemical properties of X depend on the value. Now, let's start with Y. Y represents the atomic mass. And the atomic mass is simply the number of protons and neutrons in the nucleus of an atom. Now, the neutron does not determine the chemical behavior. Now, while Z is the proton number, and the proton number determines the identity of the atom. Sodium is sodium because it has 11 protons. Oxygen is oxygen because it has 8 protons. So the value that determines the chemical properties is the proton number, and the proton number is used to determine the number of electrons in that atom. So Z is our interest, and the correct option that tells us that Z is our interest is the option D. Question 37. The atom copper 6429 and zinc 6530 have the same number of okay, now let's bring this out. Copper 6429, zinc 6530. Now this number is the proton number, so clearly proton numbers are not the same. This number is the atomic mass. Clearly again, atomic mass not the same. This is 64 and this is 65. Now let's show and the electron number too. If the proton number is equal to the electron number, that means we have 29 electrons for copper and 30 electrons for zinc. Again, not the same. Now, one more subatomic particle is the neutron, and the neutron is deduced by subtracting the proton number from the atomic mass. So let's do that for copper. That will be 64 minus 29. 64 minus 29 gives us 35 neutrons for copper. And then for zinc, 65 minus 30, that gives us 35 neutrons. So from what we can see, proton numbers not the same, electron numbers not the same, atomic mass not the same. However, neutrons are equal. So our correct answer is the option C. Question 38. The atomic number of an atom would be equal to its mass number if... Okay, now let's pretend X is an atom, and it's saying that the atomic number of an atom would be equal to its mass number. Now the number written at the bottom is the atomic number. So let's say we have the letter Z here, and then the number written at the top is usually the mass number represented by the alphabet A. So they are asking us, Under what condition would the atomic number of an atom be equal to the mass number? Option A has a high charge to mass ratio, does not contain neutrons, has a totally filled valence shell, exhibits isotopy. Now let's look at the situation where we have 1 and 1 for an element called X. Atomic mass, proton number. If we try to calculate the number of neutrons, this would give us 0, because number of neutron is equal to atomic mass A minus proton number Z. So 1 minus 1 is 0. So for the atomic number of an atom to be equal to its mass number, it simply means that that particular atom should not contain any neutron. And interestingly, there is an element like that. That element is the first isotope of hydrogen called protium, represented as H11 or P11. So our correct answer is does not contain neutrons. Question 39. The atomic number of an isotope of hydrogen is equal to its mass number because the atomic number of an isotope of hydrogen. So let's say atomic number is, let's use numbers now. Let's say it's 1 is equal to its mass number 1 as well, because mass number is 1, atomic number is 1, because it, so clearly here the difference here is that when we check the number of neutrons, that will be atomic mass 1 minus proton number 1. That gives us 0. So the atomic number of an isotope of hydrogen is equal to its mass number because it does not contain neutrons. That's all we've got in here. So our correct answer is the option A. Question 40. The atomic number of chlorine is 17. What is the number of electrons in a chloride ion? So if the atomic number of chlorine is 17, it means that chlorine also has 17 electrons, since the number of protons is equal to the number of electrons. Now in chloride ion means that a chlorine atom has gained an extra electron, so it has a charge of -1. Therefore proton number is still 17. However, because of this -1, we now know that there is an extra electron. So while the configuration of chlorine atom would now be 287, the configuration of chloride would be 288 because of the extra electron that has just been gained. So the atomic number of chlorine is 17. What is the number of electrons in the chloride ion? So the number of electrons would be 18 electrons if we add this up. So our correct answer is the option A. Question 41. The Bohr model of the atom proposed the existence of. Now, Niels Bohr, in his model of the atom, seeks to really explain the Rutherford's model of the atom. The Rutherford's model of the atoms. So, of the atom. So, the model here simply explains how the electrons actually move in the shells. How the electrons move in the shells. So the Bohr's model of the atom proposed the existence of electron shells. Option C. Question 42. The conclusion from Rutherford's alpha scattering experiment is that, now in this very interesting experiment where Rutherford used the gold foil experiment, he allowed positively charged particles to pass through the gold. He bombarded the gold foil, and he observed that a huge number of his positively charged or alpha particles pass through the gold foil, and then however a small fraction was repelled. Now let's look at it this way. Alpha particles are positive in nature, and for anything to repel them, it means that that species must also be positive, because like charges repel, unlike charges attract. So that is one, that we now know that the center of the atom has a positive charge. That's the only reason why some of our alpha particles got repelled, because they encountered a like charge. Then the second observation or conclusion is that the fact that majority of the alpha particles just pass through the gold foil shows that the atom is mostly an empty space with a small positive nucleus. That's why a lot of the particles just went through. So based on these statements, let's look at our options. Emissions from radioactive substance consist of three main components. No. There is a nuclear pull on orbital electrons. No. Atoms are mostly empty space with a small nucleus. This resonates with the information we have here. So option C becomes our correct answer. Question 43. The energy evolved when magnesium burns in air is in the form of. Now, when metals burn in air, light is produced and heat is also produced. Now, both the light and the heat are produced because of the movement of electrons. The movement of electrons from one energy level to another. And different metals produce characteristic colors. There is this experiment called the flame test, where metals, when passed through a flame, produce characteristic colors. So that explains the light. And then as well, heat is produced when electrons jump from one energy level to another. So our correct answer is A. Question 44. The existence of two or more forms of the same element in the same physical state is known as, for example, carbon is known to exist as charcoal. Carbon is also known to exist as diamond. Carbon is also known to exist as coal. It's also known to exist as graphite. Now, these are all forms of the same element in the same physical state of carbon. This concept or phenomenon is called allotropy. Allotropy. Apart from carbon, sulfur also exhibits this phenomenon. So we have things like rhombic sulfur, monoclinic sulfur, plastic sulfur, and even amorphous sulfur. So our correct answer is the option C, allotropy. Question 45. The following are miscible with water. Miscible means either they will dissolve in water or they are soluble in water. Or they will mix with water to form one solution. Now, to answer this question, see, looking at all these compounds here, they are all organic. They are all organic compounds, and usually organic or non-polar. Organic compounds usually are insoluble in water because water is polar. So for anything to dissolve in water, it also needs to be polar. But these compounds here, because they are organic, they are non-polar. So typically, they should not dissolve in water. However, water exhibits a unique type of bonding called hydrogen bonding. And any organic compound that is able to form hydrogen bond with water will dissolve in water. For example, if I pick ethanol, CH2H5OH. Now, if you look at the formula for ethanol, there is the oxygen and the hydrogen. There is a bond between this oxygen and the hydrogen. If we pour ethanol in water, the hydrogen from ethanol would form a hydrogen bond with the oxygen in water. Now, this is a hydrogen bond, and because of the formation of this bond, this compound, even though it's non-polar or organic, it becomes soluble in water. So methanol is a primary alcohol. All primary alcohols can form hydrogen bond with water because of their small structure. Methanoic acid is a simple alkanoic acid. Again, because of its simple structure, it can also form hydrogen bond with water. Ethanoic acid is also a simple alkanoic acid and can form hydrogen bond with water. Now, ethyl ethanoate, which is an alkanoid, because of its structure having an alkyl group, two alkyl groups that would not allow for the formation of hydrogen bond, will be insoluble in water. This knowledge is gotten from organic chemistry, the solubility of organic compounds in water. You can as well get this knowledge from chemical bonding, talking about the properties of ionic and covalent compounds. So our correct answer is A. Only ethyl ethanoate will not dissolve in water because it cannot form hydrogen bond with water. Question 46. The following gases are diatomic, except diatomic simply means having two atoms. Diatomic means having two atoms. Di Di is from the Greek word meaning two. Now, nitrogen exists as a diatomic gas. Hydrogen exists as a diatomic gas, or if you like, molecule, diatomic molecule. Helium is a group 8 element, and because the group 8 elements already have an octet or duplet configuration, that's in the case of helium. Now they have octet or duplet configuration. That means their outermost shell or their valence shell is filled up. These atoms will not combine with themselves or even with another atom. For that reason, they exist as monoatomic gases in the atmosphere. Monoatomic because of their unreactive nature, because of their filled valence shell. They will not take part in chemical bonding, in chemical reactions. So this is monoatomic. So it exists as just He. Fluorine is a halogen, group 7, and the group 7 elements are known to exist as diatomic molecules. So the only gas here that is that is not diatomic is helium. Question 47. The isotopes of neon are represented by the symbols 20X, 21Y, and 22Z. The relationship between X, Y, and Z is now. We are going to solve this question by looking at what X, Y, and Z represent. X, Y, and Z represent proton number, and the proton number determines the identity of the atom. Neon is neon because it has a particular number of protons. That is the first idea. The second idea is the concept of isotopy. Now, these three atoms are clearly isotopes because clearly the fact that they carry the same symbol means that they are atoms of the same element, and being atoms of the same element, their proton numbers will be the same, which is their identity. So what it means here is that X is the same as Y, and Y is the same as X as well, and the same as Z. So let's check which of our options satisfies this condition. Clearly it's option D, and that's our answer. Question 48. The mass number of an atom of an element is the sum of its. Now, mass number, also called atomic mass, is represented by the symbol capital A. It is simply equal to the number of protons plus neutrons in the nucleus of an atom. So the mass number of an atom of an element is the sum of its protons and neutrons. So straight up, we pick that as the answer, option A, protons and neutrons. Question 49. The mass of an element is 27 and its atomic number is 13. What is the composition of the nucleus of this atom? So let's pretend that the atom is represented by the symbol X. if the mass of the element is 27, the mass number is written at the top, and the atomic number, which is same as the proton number, is 13, written at the bottom, what is the composition of the nucleus? Now, in the nucleus of every atom, we simply have the protons and the neutrons, and the sum of protons and neutrons in any atom is equal to the mass number or atomic mass. And in this case now, the mass number or atomic mass of this element is 27. So what that tells us here is that we know that 13 is the proton number, so let's plug in 13 here, but we don't know the neutron number yet. The atomic mass is 27, so 27 minus 13 tells us that there are 14 neutrons. That means the composition here would be 13 protons and 14 neutrons. So our correct answer is the option A, 13 protons and 14 neutrons. That is the composition of the nucleus, because like I said, in the nucleus we have only the proton and the neutron. It is not electron because electrons are not found in the nucleus, so this disqualifies it. Electrons are not found in the nucleus, and then this is the opposite. Question 50. The mass spectrometer can be used to measure the mass of. Now, the mass spectrometer is used for several purposes. Like in the case of the electron, it is used to measure the mass to charge ratio of the electron. However, looking at the options here, the size of the atom is important here, so that when we know the size of the atom, we can then determine the subatomic particles. So the mass of the mass spectrometer is primarily used to measure the mass of an atom by factoring in the protons, the electrons and the neutrons. So what is encompassing here, what covers everything here, is the atom. So we'll pick the atom as our answer. Because the neutron, the electron and the proton are all subatomic particles. They are subatomic particles. So the mass spectrometer measures the mass of the atom. And that is our answer, option D. The negatively charged particle in an atom is. Now, an atom has three subatomic particles: the proton, the neutron and the electron. The proton has a positive charge, the neutron is neutral. That's the word neutron is from the word neuter, meaning neutral or no charge, and the electron has a negative charge. So the negatively charged particle in an atom is the electron, and that gives us option B as the correct answer. Question 52. the number of unpaired electrons in an atom of an element Q is, okay, now Q has 8 protons. This means that Q also has 8 electrons. Now, to determine the number of paired or unpaired electrons, we have to use the electronic configuration using the subsidiary quantum number or the orbitals or SPDF notation. We're going to apply the Aufbau's principle that electrons will occupy orbitals of lower energy level first before occupying orbitals of higher energy level. So I'm going to start by writing down the Aufbau's formula, which we're going to use to answer this question. One s is the orbital with the lowest energy level, followed by 2s, then 2p, then 3s, then 3p, then 4s, and it goes like that. So let's look at this configuration. 8 electrons. The first orbital with the lowest energy level is the 1s, and s can take a maximum of 2 electrons, so we're left with just 6 electrons now. The next orbital with the lower energy level is the 2s. Again, s orbital takes maximum of 2 electrons. We're now left with 4 electrons. The next orbital is 2p, and p can take a maximum of 6 electrons, but we're left with just 4. So this is the configuration. Now we have to apply Horn's rule of maximum multiplicity. Horn's rule to determine the paired and unpaired electrons. Horn's rule of maximum multiplicity. Now, Horn's rule states that when electrons occupy orbitals, they will do so singly before pairing takes place. Now, the 1s has just one suborbital, and because we have 2 electrons here, so 1, 2. The arrows are pointing in the opposite direction because of Pauli's exclusion principle, which states that 2 electrons cannot have the same spin. 2 electrons occupying the same orbital cannot have the same spin. If one spins clockwise, the other one spins anti-clockwise. The next one is the 2s. Again, s orbital has just one suborbital, so we have it there. Now the next orbital is the p orbital, and we said that the p orbital can accommodate a maximum of 6 electrons. That means if we split this, we're going to have 3 suborbitals. So we're going to have 3 suborbitals. So 2p, but remember we have just 4 electrons in this case. Now applying Horn's rule now. Horn's rule is saying that when these electrons will occupy these suborbitals, they will do so singly. 1, 2, 3. All the suborbitals must obtain an electron before we can start pairing. Now we've exhausted 3, we're left with only 1 electron, so the last electron will occupy this orbital, so it comes here. That means these orbitals are unpaired, so we have 2 unpaired orbitals. That is 2 orbitals carrying just 1 electron. So let's look at our options. Which orbital or which option tells us we have 2 unpaired electrons? It's the option A. Question 53. The region around the nucleus where electrons can be located. Now, any region outside the nucleus that there's a possibility of locating an electron is called an orbital. Any region outside the nucleus where it's possible of locating an electron is called an orbital. So our answer is the option A. Question 54. What is the mass number of an element having 20 neutrons, 15 protons, and 15 electrons? Now we ask ourselves, what is the definition of mass number? Mass number is simply the sum of protons and neutrons in the nucleus of an atom. So since we know that there are 15 protons and 20 neutrons, if we add this up, it should give us 35. That means the mass number of this atom or element is 35, and that gives us option B as the answer. Question 55. What is the mass number of an element if its atom contains 10 protons, 10 electrons, and 12 neutrons? The definition for mass number is the sum of protons and neutrons in the nucleus of the atom. And from the information we're provided, the proton number is 10 protons, the neutron number is 12 neutrons. 12 plus 10 gives us 22, so the mass number is 22. So our correct answer is the option A. Question 56. When an element can exist in two or more forms in the same physical state, the element is said to exhibit allotropy is our answer. The correct answer is B. Question 57. When sodium atom forms the ion, it achieves a noble gas configuration, its atomic number increases, it gains 1 electron, it gains 1 proton. Now let's look at sodium atom. Sodium atom has 11 protons, and in every atom the number of protons is equal to the number of electrons. So if sodium has 11 protons, it means it has 11 electrons. Now we are looking at sodium ion. We're looking at sodium ion. That means sodium ion has a positive charge, a plus. What this tells us here is that there are more protons than electron, and it's just a plus, so it's a +1. It means that it has 1 proton more than electron. So even though the proton number is still 11, but what this tells us is that the only way that the proton number would be more than the number of electron is that sodium has lost 1 of its electron. So 11 protons and then 1 electron was lost, so we now have 10 electrons. 11 minus 10 gives us +1 on the side of protons. So, and let's look at the configuration. If the proton number is same as the electron number, configuration becomes 2, 8, 1. That gives us 11. This is not a noble gas configuration. A noble gas configuration shows us that the valence shell is filled up. Now, for sodium ion, let's check the configuration. Electrons are now 10, so that is 2, 8. This is a noble gas configuration. So when sodium atom forms the ion sodium plus, it achieves a noble gas configuration. This is true. Its atomic number increases. Its atomic number does not change. Number of protons remain unchanged. It gains 1 electron. No, we've seen here that when it becomes an ion, it actually loses 1 electron. It gains 1 proton. Again, we have seen here that the number of protons remain intact. So our correct answer is the option A. It achieves a noble gas configuration. Question 58. Which of the following elements exhibits the same chemical property as the atom X3517? So let's bring it out. X3517. Now this is proton number, and proton number also tells us the number of electrons. Now the chemical property is determined by the number of valence electrons. The number of valence electrons. So if the proton number is 17, the number of electrons will also be 17. The configuration will now be 287. So it's asking us which of the following elements exhibits the same chemical property as the atom 3517. So we also need to look for another atom or an option here that has the same proton number of 17, which would give us the same number of electrons, which would also give us the same electronic configuration. So the option here with the same number of protons, which is atomic number, which will now give us the same number of electrons, is the option A. Question 59. Which of the following gases contains the highest number of atoms at STP? The highest number of atoms at STP. Now, we are going to apply the Avogadro's principle here. The Avogadro's principle states that 1 mole of any substance will occupy 6 or will contain 6.02 times 10 raised to the number to 23 particles. That 1 mole of any substance at STP will contain this number of atoms. So we're going to work it out for each of them. If 1 mole will contain this, then let's start with oxygen. 3 moles of oxygen will then contain how many? If we work that out, if we follow this principle, that will be 3 moles will contain how many atoms? So that will be 3 moles times 6.02 times 10 raised to the power 23 atoms. Now based on this, it clearly shows us here that the atom with the highest number of moles will contain more atoms. So 6 moles, it means that 6 moles of neon, which is the highest number here, times 6.02 times 10 raised to power 23 will contain the highest number of atoms at STP. So that leaves us with 6 as our, option B as our answer. Question 60. Which of the following is not true? Not true of the elements represented by the symbols. Now, let's bring them out. A and B. Then Y, C and B. Now, we can clearly see that B represents a proton number. So, proton number is the same. So we're cool with that. But the atomic mass here is A, atomic mass here is C. So atomic masses are not the same. So what this tells us here is that the fact that their proton numbers are the same means that they are atoms of the same element. And when we have atoms of the same element, because they have the same proton number but different atomic mass, then we are looking at the concept or the phenomenon of isotopy. That means X and Y are isotopes of the same element. So let's check our options. A says X and Y have the same number of electrons. This is true, because if their proton numbers are the same, it means that their number of electrons will be the same, because we said that proton number is the same as electron number. So option A is true. X and Y have the same number of protons. That is also true. We've seen it here. B represents proton number. Then C, X and Y are isotopes. This is also true, because they have the same proton number but different atomic masses. That means that they are isotopes of the same element. Then option D says X and Y represent atoms of different elements. Proton number determines identity, and their proton numbers are the same, so they cannot be representing atoms of different elements. So this is not true. So our correct answer is the option D. This statement is not true. Question 61. Which of the following is suitable for determining different isotopes present in an element which exhibits isotopy? Now let us look at the root of this question. It's asking us which of the following method would determine the different isotopes. To answer this question, we need to know what all these apparatus are for. The cathode ray tube was one of the is an instrument that we can use to determine the presence of charged particles. The cathode ray tube can be used to determine the presence of charged particles. The gigamolar counter is used to detect the presence of radiations. And let's also get something here. The question is asking us for isotopes. Not all isotopes are radioactive. Isotopes that emit radiation are called radioisotopes. So this question is about isotopes in general and not specific to radioisotopes, which are the isotopes that emit radiations. The gigamolar counter is used to detect the presence of radiations from radioisotopes. The sensitive weighing balance, of course, is to measure the mass of substances, but this is unable to measure the mass of isotopes as they are quite small. And the mass spectrometer is used to actually measure the mass of the different isotopic species. It uses what we call a mass filter. It uses a special device within it called a mass filter. So it's able to separate or isolate or detect the different isotopic species. So our correct answer in this case is the option D, the mass spectrometer, for the following reasons. The cathode ray tube is used to detect the presence of charged particles. The gigamolar counter is used to detect the presence of radiations like gamma radiations, alpha radiations, and beta radiations. And we're focused on isotopes here, not on radioisotopes, which are the isotopes that emit radiation. And then the sensitive weighing balance is still not sensitive enough to measure the mass of the isotopes as they're quite minute. So our answer is the mass spectrometer, option D. Question 62. Which of the following pairs illustrate isotopy? Both 1 in and both 2 in. This is not isotopy, this is isomerism. These two compounds are isomers. In fact, they are positional isomers. The 1 and the 2 indicate the position of the double bond. So this is positional isomerism. Oxygen and ozone, no, these are totally different molecules. While oxygen is O2, ozone is O3, so they are totally different molecules. Ortho hydrogen and parahydrogen, again, this is another form of isomerism. Now hydrogen and deuterium is the answer. The hydrogen being referred to here is protium. That is the first isotope of hydrogen, and then deuterium is the second isotope of hydrogen, respectively presented as P11, D21. So protium, deuterium. So our correct answer is the option D. Question 63. Which of the following pairs of species contains the same number of electrons? Which of the following pairs of species contains the same number of electrons? Now, the numbers written here are the proton numbers. The numbers written here are the proton numbers, and the proton numbers are the same as the number of electrons. So chlorine has 17 protons. That means it has 17 electrons as well. Aluminum has 13 protons. That means it has 13 electrons. Magnesium has 12 protons. That means it has 12 electrons as well. Sodium, okay, let me skip sodium. Let me go to neon. Neon has 10 protons. That means it has 10 electrons. Carbon has 6 protons. That means it has 6 electrons. There's something wrong with this particular sodium, so I need to flag this question. Because if it is just sodium atom, then it should have 11 protons. And if it has 11 protons, it will have 11 okay, so it's supposed to be sodium. It's supposed to be sodium ion. So yeah, it's supposed to be sodium ion. Now sodium, if it has 11 protons here, because of it has lost one of its electron, it actually has 10 electrons. So this is supposed to be sodium ion. So our correct answer now should be sodium ion and neon. Question 63. Which of the following pairs of species contains the same number of electrons? Now, let's pick each option and look at them. Sodium ion, the number of proton is 11, and because it is a sodium ion, it has lost one of its electron. So instead of having equal number of electrons as the protons, that's 11 electrons, it has 10 electrons. It has 10 electrons. So here we have 10 electrons. Then magnesium has 12 protons. This magnesium atom, so it's going to have 12 electrons. So 10 electrons against 12 electrons, no. The next one, chloride, chloride has 17 protons, but because it has the negative sign, the -1 tells us that it has gained an extra electron. So that means it has 18 electrons, 2, 8, 18 electrons. Then neon has 10 electrons. 10 protons, so it also has 10 electrons. So again, the numbers do not tally, so no. Magnesium ion, now magnesium has 12 protons, but it has a charge of 2+ here, meaning that it has lost 2 of its electrons, so the remaining electrons are 10 electrons. As against aluminum ion is 13, so it has 13 protons, so it's supposed to have 13 electrons as well, but the 3+ sign tells us that it has lost 3 of its electrons, so it has only 10 electrons left. Now the numbers tally, so we can just stop at option C, and that is our answer. Question 64. Which of the following processes is a physical reaction? Which of the following processes is a physical reaction? Now, electrolysis is a chemical change. Hydrolysis is a chemical change. Neutralization, it's a chemical change. Now let me go back and define each of them. Electrolysis is a chemical change. It involves the decomposition of a compound by the passage of a direct current into the molten or aqueous salt of a compound, while hydrolysis is the splitting of water into its components. For example, if hydrolysis is the splitting of a compound by the addition of water. It is the splitting of a compound by the addition of water. Neutralization, of course, is the reaction between an acid and an alkali to form salt and water only. Allotropic change is simply a change of state. It's simply a change of state. The same element changes form. So for example, coke can be heated at high pressure to get graphite. Wood can be heated to get let me use the example. Sugar charcoal So which of the question 64, Which of the following processes is a physical change? Electrolysis is a chemical change. It involves the decomposition of a compound by the passage of a direct current into its aqueous or molten salt. For example, the electrolysis of water. Hydrolysis is also a chemical change. It is the splitting of a compound by the use of water to break the bonds between its molecules. And then neutralization is a reaction between an acid and an alkali to form salt and water only. So chemical change. Now allotropic change is a form of change of states. It's just a form of change of state, so it's a physical change. For example, we can have one form of carbon being converted to another form of carbon. For example, the Acquisition process. The Acquisition process is the industrial process where we are able to manufacture artificial diamond using coke. So allotropic change is our physical change. So our correct answer is the option D. Question 65. Which of the following scientists discovered the electron? Rutherford discovered the electron. James Chadwick discovered the neutron. Joseph John Thomson discovered the protons. Or if you like, the Plum-Hording model of the atom. And then Avogadro has nothing to do with the atoms. Amedeo Avogadro has nothing to do with the atoms. So our answer is the option A. Question 66. Which of the following scientists discovered the neutron? Rutherford discovered the electrons. James Chadwick discovered the neutron. So we can just call it a day here. Option B is our answer. Question 67. Which of the following species correctly represents an ion of M with 13 protons and 10 electrons? So if M has 13 protons, that means proton number is 13, but it has 10 electrons. Now proton number is supposed to be equal to electron number, but right now we have 13 protons and just 10 electrons. This clearly tells us that this metal has lost 3 of its electrons. It has lost 3 of its electrons. So that means it has 3 protons extra. So M will now become 3 plus. So let's check which option has M13 3 plus. So it's the option B. Question 68. Which of the following species determines the chemical properties of an atom? The neutron contributes to the mass of the atom. The proton determines the identity of the atom. The nucleus is where the proton and the neutron are housed. The electron determines the chemical properties of an atom. Not just the electron, but the valence electrons, that is the electrons in the outermost shell. So looking at these options, our viable answer is the option A. Question 69. Which of the following will decrease in mass when heated in air? Decrease in mass when heated in air. Now, magnesium ribbon, when heated in air, will combine with oxygen, of course, to form magnesium oxide. So this would increase in mass. So this would increase in mass when heated in air. Powdered sulfur, also when heated in air, will produce sulfur dioxide. So this would also increase in mass. Calcium trioxocarbonate, when heated in air, calcium trioxocarbonate 4, when heated in air, will break down to produce calcium oxide plus carbon dioxide. Now, clearly, if this reaction is, so clearly this will be a gas, some of this gas will escape, so there will be a decrease in mass. Then magnesium tetraoxosulfate 6 heptahydrate. Now, when it is heated in air, it is going to lose its water of crystallization, so that we're left with only magnesium sulfate crystals. So this clearly would also decrease in mass. So we'll see a decrease in mass for 3 and for 4. And which of our options gives us that? That is option B. So our answer is B. 3 and 4 will lead to a decrease in mass.